consists of two equal point charges of plus q are placed along the x-axis at a distance d apart as shown in the figure. Assuming that the left-hand charge is at x equals 0, the variation of electric field intensity E with x is represented by. There are two charges, both are plus q charges. We have to get the variation of electric field intensity with distance from this point. It is given as x value is 0 at the position of charge in left hand side. We know that electric field intensity is the force on plus 1 Coulomb. Then if we are placing plus 1 Coulomb at this place, the force due to this plus 1 Coulomb is plus q is greater than this one because of it is the distance between these two charges is smaller value. But when moving this charge along this line, we know that the force due to this force is increasing than this one. Therefore, and we have to remember that plus there is a repulsive force. Then electric field is in this direction for this side, and it is in opposite direction for this side. When moving plus 1 Coulomb near to this point charge, force is opposite. It means electric field intensity is decreasing, and at this midpoint 0, after passing 0, it is increasing in opposite direction. It is like this. After that, again, when plus 1 Coulomb is at this side, it will move under force in this direction. Again, initial direction. It is normal curve from the point charge. Then we can obtain third one is the correct answer. A body is charged to a value of minus 32 Coulomb. If the electron charge is equal to minus 1.6 into 10 to the power minus 19 Coulomb, then the excess number of electrons exciting on the body. We know that charge is number of electrons into charge of an electron. Then we can subject number of electrons, charge divided by charge of an electron. Charge of the object minus 32 divided by minus 1.6 into 10 to the power minus 19. Divide by 16, 0.1, divide by 16, 2. 2 divided by 0.1 means 20. 20 multiplied by 10 to the power 19. It means 2 multiplied by 10 to the power 20. We can obtain this one is the correct answer. Two identical bodies, each of mass m, kept at a distance r apart on the x-axis as shown in the figure, are released from rest. If the influence of other bodies on these masses are negligible, which of the following graphs best represent the variation of velocity v of bodies with their distance r? Now they have given there are opposite charges, plus and minus. We know that opposite charges are attracting when moving charges towards each other. The electric force is increasing as a result of increasement of electric force. Velocity is increasing when r value is a small value. So we can obtain third one is the correct answer. The minimum amount of charge which should be placed on each body in order to counterbalance the gravitational attraction between bodies mentioned in question 47 above means above 1. It means mass of two objects, simple M, and separation, capital R. We can consider gravitational force should be equal to electric force in magnitude, but opposite direction. Gravitational attraction G m over r squared, but there are same masses, then we can use simple M for both masses. It should be equal to electric force 1 over 4 pi epsilon charge, same charges, Q into Q, I will consider Q squared over R squared. Now we can simplify and find the value of Q. R squared is cancelling. 4 M squared 5 epsilon G root. It is the value of Q. We can get 4 root 2 M squared root M square root of 5 epsilon G. Then we can get the answer is fourth one. Two small spheres of equal masses are suspended from two identical light inextensible strings. The free ends of strings are connected to a common point at ceiling. On the sphere has plus Q charge and the other has charge plus 2Q. If the string attached to Q makes an angle theta with the vertical, the angle at the other string makes the vertical V. We know that this repulsive force is an interaction force. It means equal and opposite. There are two charges, but we know that when getting electric force, we have to get product of charge. Then there are equal and opposite charges. If this angle is theta, this one also theta, then same as theta. Fourth one is the correct answer. Charges plus Q and minus 2Q are placed at corners of equilateral triangle. As shown in the figure, the point along the line XX dash at which the electric field intensity is most likely to be 0. Plus Q minus 2Q. We know that electric field intensity means charge force per unit charge. Unit charge means plus 1 Coulomb. I will consider a point at this side. Then plus 1 Coulomb, which is the testing charge. There is a repulsive force due to this one, and there is a repulsive force due to this charge, and there is an attraction due to minus 2Q. Therefore, we can consider it should be like T, point T. Then considering this point, we have to consider that this one is the largest charge. The neutral point should be a greater distance from the larger charge. Then T is the neutral point, field intensity 0. This one is the correct answer. A conducting sphere and concentric conducting spherical shell carry a charge plus Q and minus Q, respectively as shown in the figure. The variation of electric field intensity E with the radial distance R from the center O is best represented by. When considering conducting shell, we know that charge is at the inner surface because of the minus Q charge of this spherical shell is attached to plus Q charge in this one. Therefore, plus Q is in this surface, minus Q is in this surface. Field lines are between this sphere and spherical shell. Therefore, there is no an electric field at this region, 0, After passing this point, there is a field like this. We know that field is decreasing with r, it is inversely proportional to r square. After passing this point, there is no any charge, therefore again it is 0. Then second one is the correct answer. If a water molecule is placed in the electric field shown in the figure, which orientation would it take in order to minimize its energy? We know that when considering water, oxygen has a minus charge, hydrogen has a plus charge. Minus charge is attracting to positive terminal. It means lower state. This one is positive, this one is negative. Therefore, electric field is in upward direction. Oxygen should be this side, then hydrogen should be this side. Then correct position is second one. Second one is the correct answer. Two identical conducting spheres A and B carry equal charges. The spheres are separated by a distance which is much greater than their distances. The electrostatic force acting between them is F. Now third identical uncharged conducting sphere is first made touch A and second B, then removed. The new value of force acting between A and B. A, B. There is the same charge. Then we can obtain F equals 1/4 epsilon Q into Q. It means Q squared over R squared. These all values are constant. Then we can get F directly proportional to Q squared. Then ideal third object but without charge is touching with this one. When touching with this one, this charge is spreading equally between two objects. Then Q should be half for the second situation. It is Q over 2. After that, it is touching with this one. Now it has a Q over 2 charge. This one divided by 2 is the net charge in this one after the contact. Then 3 over 2 divided by 2 means 3 over 4Q. Final charge of this object is 3Q over 4. Now, new force is directly proportional to Q over 2 multiplied by 3Q over 4. We can divide this proportional relationship. 1 divided by 2. F divided by F dash. Q squared and Q cancelling. 1 divided by 3 over 8. Then we can subject F dash. It is 3F over 8. Then answer is 4. The figure shows a spherical conducting shell. The point charge plus Q is placed at the center of the shell and charge minus Q is given to the shell. Finally, the shell will have, you have to get inner surface and outer surface charge. There is a plus Q point charge inside the shell at the center. Therefore, the induced charge in inner surface is minus Q. It is equal and opposite to the discharge. Normally, they have given minus simple Q charge for the shell. It is spread in outer surface according to Faraday laws. And due to the induction, there is another charge. It is equal and opposite to this one in outer surface. Then net charge in inner surface minus Q, net charge in outer surface Q minus simple Q. then we can get third one is the correct answer.